Let's factor quadratic-like expressions. So this actual expression here is quadratic. We're going to use it, though, to factor some other things in just a moment. It's quadratic because it's in the form ax squared plus bx plus c. We see that a is the coefficient of x squared, so a is 2. B is the coefficient of x, which is -7, and c is the constant, which is 5. And we're going to factor by grouping. Okay, there are other ways to factor, but this video is going to show you by grouping. And if you need more practice on grouping, there are other videos we've made for that. So for factoring by grouping, you're going to find the AC product, which just means take A and take C and multiply them together. So A was 2 and C was 5, so the product of those is 10. We write all the natural number all the natural number factors of 10, 1 and 10, 2 and 5. And then this third sign here is going to be super helpful. The third sign is going to tell us a few things. So, third sign positive tells us, first off, it tells us we're going to add to get the middle number, which in this case is the coefficient of x. So then we're going to use the same sign for the numbers as our middle number. And then it's going to tell us when we actually do our factorization that our factorization will have the same signs in our two sets of parentheses. And we're going to use that middle sign. Okay. So our third sign is positive, which means we're going to add to get -7, but we're going to use the same sign. Okay. So that means we had a negative sign right here. So we're going to put a negative for each one of these, and then we're going to add the numbers. So -1 and -10, well, that's a -11. So that doesn't give us -7 like we're looking for. -2 plus -5, that does give us -7. So this is the pair we're going to use. We are going to rewrite this middle term in terms of those values with an x. So we're going to have 2x squared minus 2x minus 5x plus 5. So verify, I'm going to highlight this. Do you see that the two things I've highlighted? -2x, -5x, when you combine them, you get -7x. Awesome. Okay, now we're going to factor by grouping. You can use parentheses, but I encourage students not to do that unless they're very, very careful with the signs. I like to just underline pairs of things that we're looking at. Okay, so we say, what do the first two things have in common? 2x squared minus 2x, you're going to ignore the back two terms for now. What do the first two terms have in common? 2x squared minus 2x. We can factor out a 2. We could also factor out an x. So then we have 2x times what gives me 2x squared? Well, you're missing an x. And then we have 2x times what gives me -2x minus 1. Okay, then we look at the back and we say, well, what do these guys have in common? And you may say, well, they both have a 5. Okay, so let's try. What happens if we factor out a +5? Okay, well, we get 5 times what gives me -5x? And -1x. Okay, then we say 5 times what gives us +5? A +1. And then we compare. Ideally, every time you do factoring by grouping, this last set of parentheses, the thing that remains once you do your factorization, should match for each of them. And you see ours does not. So we didn't factor it correctly. If you notice, it's off by a negative sign. So we can actually factor out a -5 instead. That will be actually what we should do. So let's erase this, and we're going to do a -5. I showed you that so you would know, what it looks like when you don't get the same thing, how you know to flip and make a negative. So they both have a 5, but if you notice, the signs are different, right? The coefficient of this one is a negative. So if we want a positive 1x in here, we need to pull out a -5. So -5 times x gives us -5x. -5 times a -1 Negative 5 times negative 1 gives us positive 5. Okay, so I want to pause for a second and I want to do some scratch over here before we continue. So if we're doing some scratch, I want you to factor 2x times m minus 5m. Well, you see both of these have an m in common. So they both have an m right here. And then we read off the rest, right? 2x minus 5. Okay, so but actually look at what we have. If this was m in both of them, do you see that our m is x minus 1 in both of those? Okay. And most students are very comfortable when I do this factorization. All we do is we rewrite the m out here, and then you saw me read off the rest. Okay, so 2x minus 5 came from this 2x and this minus 5. So we're going to do the same thing up here. So we write down what they have in common, m, but in this case it's x minus 1, and then we read off the rest. So we have 2x minus 5. So 2x minus 5 goes in here. Does that make sense? Then you take a moment and you FOIL it back out and you make sure you get what you should get, what you started with. Okay, now one thing I want to point out, it says when we looked at what our third sign, positive, told us, factorization will have the same signs, and we're going to use the middle sign. What was our middle sign? It was negative, right? So our factorization had 2 negatives. It's perfect, we did it correctly. Okay, so we just take a moment and look over that. You can even FOIL it. And then let's try something that builds off of this. Okay, ready? Let's try something else. So we're going to factor 2p to the 4th minus 7p squared plus 5. Now this one's not quadratic. How do you know? Kind of looks quadratic, doesn't it? It's not quadratic because the highest power of our variable is not 2. Notice quadratic was like ax squared plus bx plus c. Powers of x were 2, 1, and 0. But we say this is quadratic-like. Okay, so I'm just going to remind you what we did in number 1. So in number 1, we said 2x squared minus 7x plus 5 factored as x minus 1 times 2x minus 5. I'm going to do that just so I can scroll down. Okay, so if we're going to factor 2p to the 4th minus 7p plus 5, I want you to notice a few things. First off, notice that the powers of p are in descending order, right? Just like the powers of x, 2, 1, 0. Well, here it's 4, 2, and 0. Okay, so I want to highlight something. Let's see, what if I highlight this x right here? If I highlight that x, you notice there's an x in both sets of parentheses in the front. And that's true because when you FOIL this, you get x times 2x, you end up with x squared, right? So if you have something that's quadratic-like, it's going to have a similar property. I want you to look at p squared. Okay, so here I said x times x gave us x squared. Well, what's p squared times p squared? Because if I'm going to FOIL, I'm going to have those in the front. P squared times p squared is p to the 4th. So the way you're going to do this is you're going to compare this expression we're trying to factor with one we already know that looks very similar. Notice the coefficients and constants are the same and in the same order. 2, then a negative 7, and then a positive 5. 2, negative 7, and a positive 5. So what we're doing is we're making a substitution. We have substituted, instead of an x, we've used p squared, right? So look right here, that we have in yellow. This x has been replaced with p squared. So we're going to replace this x here in this factorization with, p squared. So we're going to have p squared minus 1, and then 2p squared minus 5. And when you have something that's quadratic-like, you're going to notice that every time you FOILed, you took the first times the first, and that gave you the leading power, usually if they were in the correct order, if x was first in your sets of parentheses. So you're usually going to try to factor it, see if it's quadratic-like, and you're going to see if the middle term's variable is what should go in the first set of parentheses. I'm sorry, in the front of the parentheses. So let's actually FOIL this one. If we FOIL it, we get 2p squared, so that's 2p to the fourth, minus 5p squared, minus 2p squared, plus 5. Well, negative 5 and a negative 2 together give you negative 7p squared plus 5. Okay, so that's going to be our strategy. Look, we have another one right below this. So I'm going to write down number 1 again just so I can see it. So number 1 was 2x squared minus 7x plus 5. We saw that that factored to x minus 1 times 2x minus 5. So let's check the variables here. This is not even a polynomial because it has fractional powers, but you can see the coefficients are the same, 2, and then a negative 7, and the constant is a 5. And the powers start out descending order, right? Highest power is 1, and then it goes 1/2, and then there isn't one, 0. So what you're going to do is you're going to say, okay, well, I'm going to look at the variable of the middle term. If I look at the variable of the middle term, w to the 1/2, and I multiply it by itself, w to the 1/2 times w to the 1/2, that's 1/2 plus 1/2. Isn't that w? And isn't that what I get when I look at the first term? The variable of the first term is just w. Okay. So we're going to take every x here. I'm sorry, wrong x. X right here has been replaced with the w to the 1/2. So we're going to take the x's in our factorization, and we're going to rewrite them as w's to the 1/2. So this is w to the 1/2 minus 1 times 2 w to the 1/2 minus 5. So like I said, I'm going to say this over and over and over again. You probably never thought about it, but when you factored something like this, 2x squared minus 7x plus 5, something quadratic with x squared in an x term, you never thought about it. But the thing you put in front of both sets of parentheses was the variable from the middle term. So let's FOIL this one just to make sure we did it right. First times the first is 2w to the 1/2 times w to the 1/2. Well, that's 2w to the 1, because 1/2 plus 1/2 is 1. Then we do minus 5w to the 1/2 minus 2w to the 1/2 plus 5. Combine these, you get negative 7w to the 1/2 plus 5. Is that what we started with? Sure is. Okay, let's do another one. So again, I'm going to write down what we did from number 1 just so we can keep re-looking at it. Okay, so you see here, very similar, 2 and a negative 7 and a positive 5, right? And the powers of y start out big and they go smaller and smaller and smaller, descending order. Check the power of the variable, check the variable in the second term. We have y to the 1/3 in the second term. Well, if you multiply it by itself, y to the 1/3, times y to the 1/3, we get y to the 1/3 plus 1/3, which is y to the 2/3. And isn't that the power of the first one? So we're going to do the same thing. We've replaced this x right here with y to the 1/3. So we're going to replace this x and this x with the same thing. So we get y to the 1/3 minus 1 times 2y to the 1/3 minus 5. And I'll let you FOIL it. But you're going to see we get exactly the same thing we started with. So our strategy is to see if it's quadratic-like, see if there's 3 terms, to see if the powers of the variable are in descending order, take the variable and its power of the middle term and multiply it by itself and see if you get the variable and power of the first term. Last term should be constant. If you do, compare it to something quadratic and then make a substitution. Okay?